Hi, my name is Sharhoz Ahmed, and in this video I'm going to discuss a topic of a differential equation, and the topic that we are going to discuss is Laplace transform. So we use the Laplace transform in order to work out the differential equations. So right now I'm going to write down a differential equation, and then I'll use the Laplace transform on that differential equation to work it out. So our second order differential equation is y double prime minus y prime minus 2y equals to 0. So it's a homogeneous second order differential equation because it is equal to 0, and it is also an initial value problem, so that y of 0 is given, that is equal to 1, and y prime of 0 is also given, that is equal to 0. So first of all, we will have to solve it by using the Laplace transform, and in the end we have to find out the value of the constants by the help of this initial value conditions. In fact, we will use these initial value conditions within the working. So let's take the Laplace of this second order differential equation. So it'll be like this: Laplace of y double prime minus Laplace of y prime minus 2, I'll take this 2 outside, Laplace of y equals to Laplace of 0. So for this one, the Laplace of y double prime is equal to s square capital Y of s minus s y of 0 minus y prime of 0 minus, now let's solve this one. So for this one, its Laplace will be equal to s y of s minus y of 0 minus 2, now Laplace of this one, y of s equals to Laplace of this one is equal to 0. Now I'll just insert the value of y of 0 and y prime of 0. So it will become s square y of s minus s times 1, and y prime of 0 is 0, so I'll write 0 over here, minus s y of s minus y of 0 is 1 minus 2 y of s, and whole thing equal to 0. So from here I'll get s square y of s minus s y of s plus 1 minus 2 y of s. So from here, here and here, I'll take y of s as common, and I will get s square minus s minus 2 times y of s, and then I will shift this negative s and this positive one onto the right side, so it will become s minus 1 on the right, so that my y of s will become equal to s minus 1 divided by s square minus s minus 2. Okay, now we will solve this fraction by the help of the partial fraction. Alright, so let me just make the factors of the denominator. So the factor of the denominator will be s minus 2 times s plus 1. So I'll solve it with the help of the partial fraction. So for that purpose I have to erase this whole thing. Alright, so s minus 1 over s minus 2 times s plus 1 will be equal to a over s minus 2 plus b over s plus 1. Now I'll multiply both sides by the denominator. So on the left side I will have s minus 1, on the right side I will have a times s plus 1 plus b times s minus 1. Alright, so now I will find out the values of a and b by comparing the coefficients. Alright, so the coefficient of s on the left side is 1, and on the right side it's a plus b. So this is the first equation. The second equation, the constant on the left side is -1, and on the right side we have a this is 2 here, s minus 2, a and minus 2b. So I will simultaneously solve these two equations, and once I'll solve it, I will get the values of a and b to be, a will become equal to 1 over 3 and b will become equal to 2 over 3. I can just solve it simultaneously and get these two answers. So my y of s will become equal to a over s minus 2. So a is 1 over 3, so it's like 1 over 3 over s minus 2 plus b over s minus s plus 1, so it's like 2 over 3 divided by s plus 1. So I will take the inverse Laplace of this whole thing. So in order to take the inverse Laplace transform, I will use the symbol L inverse on both sides, L inverse. So the Laplace transform of, I'll give you an example. Let's suppose we have 1 over s minus 4 and we have to take its inverse Laplace. So it will be equal to e to the power of this 4 multiplied by t. So that's the inverse Laplace transform. Okay, so for this purpose I will do this 1 over 3 will be written as it is. So it's like 1 over 3 Laplace inverse of 1 over s minus 2 plus 2 over 3 Laplace inverse of 1 over s plus 1. So the answer will become equal to 1 over 3 e to the power of 2t plus 2 over 3 e to the power of negative t, because over here there should be minus sign. So I can write s plus 1 as s minus 1. So this minus 1 will be written over here. So this will be the final answer for our second order differential equation by using the method of Laplace transform. So that was a short introduction of the Laplace transform and how you can use it in order to work out your second order differential equations. So I hope you understood the concept, and thanks a lot for watching this video.